In this chapter, polynomial division and the factor and remainder theorems are explained. However, before this, some essential algebra revision on basic laws and equations is included. Indices, also known as exponents, are shorthand notation for repeated multiplication. Basic operations involving indices include multiplication, division, raising to a power, and taking roots. The following are the laws of indices. The multiplication law for indices, also known as the product rule or power of a power rule, is a fundamental rule in algebra that governs the behavior of exponents when you multiply terms with the same base. Here's the rule stated: when you multiply two terms with the same base, you add their exponents. This rule holds true for any real numbers m and n, and any real number a, as long as a is not equal to 0, because raising 0 to any positive power yields to 0. Let's consider an example problem involving the multiplication law of indices. The multiplication law of indices states that when you multiply two powers with the same base, you add the exponents. In this problem, both 2 raised to 3 and 2 raised to 5 have the same base, which is 2. So, for our problem, 2 raised to 3 times 2 raised to 5 is equal to 2 raised to 3 plus 5. Therefore, 2 raised to 3 times 2 raised to 5 simplifies to 2 raised to 8. In this problem, we need to follow several steps to simplify the expression. Step 1. Multiply the coefficients. The coefficients or the numerical parts in the given expression are 2 and 3. When multiplying these coefficients, simply multiply the numbers. Step 2. Apply the multiplication law for indices, exponents, for each variable. The multiplication law for exponents states that when multiplying two expressions with the same base, you add the exponents. Let's apply this rule to each variable. For the variable x, x raised to 3 multiplied by x raised to 2 is equal to x raised to 3 plus 2. The result will be x raised to 5. For the variable y, y raised to 2 multiplied by y is equal to y raised to 3. Step 3. Combine all parts. Now, we combine the results from the previous steps. We have the numerical coefficient, 6, and the variables with their new exponents. So, the simplified expression is 6x raised to 5y raised to 3. To fully understand the multiplication law for indices, let's solve the following problems. For the last problem, let's solve a more complicated one. Step 1. Simplify the expression. First, write down the expressions. Now, multiply the expressions. Combine the terms with the same base using the multiplication law of indices or add the exponents for the same base. Lastly, simplify the exponents. So we come up to a new expression x raised to 9, y raised to 6 and z raised to 9. Step 2. Calculate the numerical value of the simplified expression if x equals 2, y equals 3, and z equals 4. Now, multiply these results together to get the final answer. Therefore, the simplified expression is x raised to 9, y raised to 6 and z raised to 9. And the numerical value is 97,710,505,984. The division law for indices, also known as the exponent rule for division, is a fundamental principle in algebra that simplifies expressions involving exponents. This law applies when you are dividing two powers with the same base. The rule states that, when you divide two expressions with the same base, you subtract the exponent of the denominator from the exponent of the numerator. It is mathematically expressed as a raised to m over a raised to n is equal to a raised to m minus n, where a is the common base, m is the exponent of the numerator, and n is the exponent of the denominator. There are special cases involving division law for indices. First is the zero exponent. Any non-zero number raised to the power of 0 is 1. Second is the negative exponents. A negative exponent indicates a reciprocal. Let us solve sample problems involving division law of indices. Step 1. Identify the base and exponents. In this problem, the base is 3. The exponent of the numerator is 8 while the exponent for the denominator is 5. Step 2. Apply the division law for indices. According to the division law for indices, when you divide two expressions with the same base, you subtract the exponent of the denominator from the exponent of the numerator. Step 3. Subtract the exponents. 8 minus 5 is equal to 3. Step 4. Rewrite the expression with the new exponent. 3 raised to 8 over 3 raised to 5 is equal to 3 raised to 3. 3 raised to 3 is equal to 27, therefore the final answer will be 27. Step 1. Identify the bases and exponents. In this problem, the bases are x and y. The exponents for x are 8 at the numerator and 3 at the denominator. The exponents for y are 6 at the numerator and 2 at the denominator. Step 2. Apply the division law for indices for each variable separately. For x variable, x raised to 8 over x raised to 3 is equal to x raised to 8 minus 3, which results to x raised to 5. For y variable, y raised to 6 over y raised to 2 is equal to y raised to 6 minus 2, which results to y raised to 4. Step 3. Combine the results. X raised to 5 multiplied by y raised to 4 will result to the final answer, which is x raised to 5 y raised 4. Step 1. Identify the bases and exponents. In this problem, the bases are the x and y. The exponents for x in the numerator are 12, the exponents for x in the denominator are 4 and 2, the exponents for y in the numerator are 9, the exponents for y in the denominator are 3 and 2. Step 2. Combine the exponents in the denominator. To combine the exponents to the denominator, we will use the multiplication law for indices, wherein we will add the exponents for the same bases. Step 3. Apply the division law for indices for each variable separately. For x variable, x raised to 12 over x raised to 6 is equal to x raised to 6. For y variable, y raised to 9 over y raised to 5 is equal to y raised to 4. Step 4. Combine the results. Finally, to find the final answer, we will just combine the results we had from step number 3. X raised to 6 multiplied by y raised to 4 will result to our final answer, which is x raised to 6 y raised to 4. Now, let's solve several problems involving zero exponent and negative exponent. In problem 1, according to the zero exponent rule, any number raised to 0 is equal to 1. Therefore, 5 raised to 0 is equal to 1. In problem 2, first, we need to simplify the expression inside the parentheses first. 3 raised d to 2 is equal to 2. Lastly, apply the zero exponent rule. 9 raised to 0 is equal to 1. Therefore, 3 squared quantity raised to 0 is equal to 1. In problem 3, simplify the expression inside the parentheses first. 7 multiplied by 2 is equal to 14. Then apply the zero exponent rule. 14 raised to 0 is equal to 1. In problem 4, simplify the fraction using the properties of exponents. 10 raised to 3 over 10 raised to 3 is equal to 10 raised to 3 minus 3. 10 raised to 0 will be equal to 1. In problem 5, by the zero exponent rule, x raised to 0 is equal to 1 for any variable which is not equal to 0. Here are several problems involving negative exponents. In problem number 1, a negative exponent means that we take the reciprocal of the base and then apply the positive exponent. 4 raised to negative 2 will be equal to 1 over 4 raised to 2. Simplifying it will result to the final answer, which is 1 over 16. To solve problem number 2, first, rewrite the negative exponents as reciprocals. 2 raised to negative 3 is equal to 1 over 2 raised to 3, which is also equal to 1 over 8. 5 raised to negative 2 is equal to 1 over 5 raised to 2, which is also equal to 1 over 25. Dividing two fractions is the same as multiplying the first fraction by the reciprocal of the second fraction. Therefore, 1 over 8 multiplied by the reciprocal of the second fraction, which is 25 over 1, will be equal to the final answer, which is 25 over 8. In problem number 3, rewrite each term with a negative exponent as its reciprocal. X raised to negative 1 is equal to 1 over x, while y raised to negative 1 is equal to 1 over y. So, the expression becomes 1 over x plus 1 over y. In problem number 4, rewrite x raised to negative 2 into 1 over x raised to 2. Simplifying it, 3 multiplied by 1 over x squared, multiplied by y cubed will result to final answer, which is 3y cubed over x squared. In problem number 5, rewrite x raised to negative 2 into 1 over x raised to 2. Therefore, 1 over x squared is equal to 16. Take the reciprocal of both sides, x squared is equal to 1 over 16. To solve for the x, we will just take the square root of both sides. Square root of x squared will be equal to x, while the square root of 1 over 16 will be positive negative 1 over 4. So the value of x is positive negative 1 over 4. I should fuck her in the Benz.